Right, we are going to talk about lenses and optical instruments. So mirrors, this would be considered an optical instrument because it is something that plays with your eyes, something that you get information from your eyes. Mirror is completely opaque. That means that you can't see through it. And it only reflects or absorbs light. And there are three types of mirrors. They all will follow the law of reflection as you guys learned it, okay, in class. There's plane mirrors, those are just flat mirrors. There's convex mirrors. These are mirrors that curve out towards you. And there's concave mirrors, or mirrors that curve in, okay, towards you. Then there are lenses. So in contrast to mirrors, lenses are transparent. That means you can see completely through them. And basically they have a curved surface and they either reflect or refract light. They can be convex, which is where they bulge out on both sides like this, or they can be concave, a lens that caves inwards. When you have glasses, you could either be convex or concave, depending on if you're nearsighted or farsighted. So how they determine that, okay, is whether or not we need the object to be smaller or whether we need it to be larger, and whether we want it to be whether it's far away from us or close to us, and how we want it to look. So a convex lens occurs when, so if you're nearsighted, the object is between 1 and 2 focal lengths, or the object is within 1 focal length, so when they're close up, and that's when we want things to appear larger to us, okay, we can't see them, all right, and they will appear larger, and we use the convex lens for that. Concave would be if we wanted it to look smaller. So if we were, let's say, looking at a, I don't know, let's see, something under a microscope or something, we might do the concave lens, a mixture of concave and convex, in order to get it to completely focus. Now, a couple new words from here are focal length. That's roughly about 22 to 24 millimeters from the eye. Okay, so there's obviously a lot of focal lengths when you're looking at something. It has to do with whether they're real or virtual. And a real image is one that essentially will look inverted to your brain, and your brain corrects it. That's what most images look like. Your brain corrects. They come through upside down, and your brain will correct it so that they are right side up. And then there's virtual images. They're actually formed behind your lens. So the lens of your eye is right on the outside here, and the image is actually formed behind it, and it actually is shown upright, and because it's formed behind the lens, your brain doesn't need to correct it. Whereas the real images, okay, are formed in front of your lens, okay, and that means that they have to be corrected because they're inverted when they see them, or upside down. So here's how eyesight works. So the structure of your eye allows you to focus on objects at varying distances from your eye. So light's going to enter your eye through the cornea. This is the cornea right here. Okay, it's a layer on the very outside. There's a convex lens, okay, convex lens, that helps you focus light rays to form all images. So basically light comes in, light comes in, light comes in, light comes in, and it forms the image. And then the retina, this area back here, okay, takes that and it converts the light into electrical signals, which leave to your brain through the optic nerve. So that's how it works. So you have all this light or information coming in. It goes through the cornea, which helps filters out bad light, goes into the convex lens right here, okay, and then is transmitted to the retina, which is transmitted to the optic nerve off to the brain. So optical instruments. These are some of the more common optical instruments. Obviously you have eyeglasses, but telescopes are going to use both mirrors and lenses in order to gather more light from faraway objects than the eye has the ability to do. So telescopes are really important when we're looking at things that are very, very far away. Microscopes are going to use 2 convex lenses with short focal lengths, okay, to magnify small, close objects, so make them bigger. Then you have camera. So, cameras fathers and bends light. Okay, so it takes it and it puts it through a lens where it will be bent, and then it allows that image to be formed on actual light-sensitive film. So all of those things are done with lenses that follow those laws of light and reflection and refraction and diffraction that we've been talking about. So I hope that makes sense. Let me know if you have any questions.